Good morning. Good morning. It's time to start. Thank you all for coming. We had a large number of people registering for this course, so we expected a big crowd, and we have some great speakers here on AI. I do want to state, by the way, I'm Pushpa Kalra, and I've facilitated this course by trying to find interested speakers in different fields of AI. If you want to learn how to use AI, I'm not sure you'll learn it from here. The way I have expected this course to go is to find out what is AI, what's going on with it, where is it being used, what are the benefits, what are the disadvantages in different fields. So each of the lectures will be on a different one. This is the general overall lecture. And then we'll also have AI in medicine, AI in agriculture, AI in the arts, in sports, so on, so that you get a brief taste of what's going on with AI. But if you think you will walk out of here and know what to do about AI, I think you and I would be disappointed. For that, John Paul brought this book, Chat GPT for Dummies, and I intend to get a copy of this. Thank you. So, today's speaker is Dr. Alina Zaire. She's currently an associate dean for research at the Herbert Wertheim College of Engineering, and she is also in charge or oversees all the programs at Malachowski Hall. That's that weird-looking building across from the Rights Union that everybody wants to know. What is that building? That's what they do there, AI. So all the projects that are in there, she kind of coordinates and deals with them. Alina is also a professor in the College of Electrical and Computer Engineering. She got her BS from Florida as well as her PhD in the early part of this century. Then she took a brief detour and went to Columbia, Missouri, but returned to UF in 2016, where, as I mentioned, she's now the director of AI Informatics Research Institute. Big title. She's got a whole page of accomplishments and awards, but just to give you an idea, she's been awarded the Teacher Scholar of the Year in 21-22, a Faculty Research Excellence Award in 2020, and a Faculty Service Excellence Award for 2021. And in 23-24, she was given the SEC Leadership Development Fellow recognition. So she looks very young to me. She looks like a high school student, but but she's very accomplished, and she's going to talk to us AI, and she'll also tell us a little more about herself. So please welcome Alina Zaire.
Okay, thank you. Good morning. Okay, so I like questions. So at any time that you have a question, please let me know. I'll bring you the microphone and we'll go through it. Okay. All right, so first, thank you for the wonderful introduction. I'm not clicking through, so let me come. No, it should work now. Yes. Okay. So I also had a slide to introduce myself. I won't go through this again. I did make a mistake and go to the University of Missouri for a few years, and then said, standing in the freezing rain, I thought, what am I doing here? And so I came back in 2016, and I met my husband here at UF, and now we have two kids, a 7-year-old and a 5-month-old. And I'm going to make sure they're Gators as well. And that's me and my PhD advisor when I graduated here from UF, and his name, no joke, was Dr. Gator. And Okay, but who am I? So I run, in my personal research, I run the machine learning and sensing lab. So we develop AI, machine learning methods to understand data. And mostly we look at remote sensing data. So what do I mean by that? It's any data we collect where we don't touch the object we're trying to learn about. So we can get really close, but if we don't touch it, we still call it remote sensing. I started my career doing work in national defense. My first uh, research efforts were IED and landmine detection for the Army. And then I had a number of summer fellowships with the US Navy, and I'm now doing underwater scene understanding and underwater mine countermeasures. And because I was doing a lot of under buried landmine detection, when I was at Missouri, I had a colleague come and say, well, if you can find buried landmines, can you find plant roots? And I have no idea, but let's give it a shot. And so now, over a decade later, we're still looking at plant roots. And it's got quite a bit of work in looking at understanding roots and soil and how they interact, and using AI to do that. And then moved into forest ecology and plant and crop stress studies. So looking for plant disease or early signs of stress so we can mitigate it before we start losing yield. And then also work in how humans interact with computers. And then we have a small project looking at tortoises in the Galapagos. And I've not convinced anyone to send me to the Galapagos yet, but we get images shipped to us and we're tracking how much do they hang out in these freshwater pools or not. So a lot of different application areas, but what ties it all together is understanding imagery using AI. And so I'll talk a little bit about the background of AI. And so maybe the first question is, what is AI? Right? And so I went to the expert, I went to ChatGPT, and I said, what is AI? And it said AI, or artificial intelligence, is the development of computer systems that can perform tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, and making decisions. This is a pretty good definition. If I ask 10 of my colleagues, we'll come up with 10 different answers, but this one's, I agree with that. And I think a key part is systems, to highlight computer systems. And generally we have to link together many different components to get an AI system to work. And I like to think about it in what I call the AI cycle. A cycle because we often build many layers of this and go around it multiple times. But we start off by developing devices and sensors to collect data. And then we also have to develop the computing infrastructure that we store that data on. And so this first component is, sensing, collecting, and managing data, which is really the backbone, the fuel of all AI. Then we take that data and we turn it into information. And so this is when people think about AI, this is what they generally think of. These AI, the AI models that take our data and make some sense out of them. And then once we have some, we have to take it back to the user, either through autonomy, like robotics, or through human-computer interaction. And then underlying all of this, increasingly more and more, we have to think about cybersecurity, and we have to think about the ethics of how our AI systems impact people. And the one other definition that doesn't come through when we talk about the system, but I think is really important to me, is AI is always that capability that's just out of reach. So it's a field that's been around for a very long time. Actually, the backbone of the models we use now are neural networks. The first development of this started in the 1940s. There was a big boom in the 80s, but I mean, this is a long time coming, right? People have been working on this technology for a really long time. And what we are trying to do, so back then it was often called electronic brains early on. What were we trying to do with electronic brains has changed. And it's never that we've achieved AI. We're always going after the next thing, right? You can think about it when, I don't know if you've used an Amazon Echo. When they first came out, we could talk to computers. It was amazing. It was like, oh my gosh, this is so cool. I can tell it to play it by song, and it plays a song. But now when my 7-year-old talks to it, never understands him, and he gets frustrated. Why won't he play this, whatever? But we no longer think about it, this amazing AI system. We're like, oh, it's the device. I can't understand my 7-year-old anymore. And so we're always pushing the boundaries there. Okay, but there have been amazing advances in AI. The current sort of approach that's capturing a lot of our attention are these large language models. I work in, as I said, with imagery quite often, and so we're focusing a lot on what we call vision transformers, or essentially large language models for images. And it's impacted many sectors. And I understand y'all are going to hear from folks talking about agriculture and medicine and other areas. But there are challenges still, okay? And so I'm going to give you, I am a professor, so I give a pop quiz, okay? So this is my pop quiz. These are handwritten characters that we've, digitized. And what do you think these characters are? What letters? I hear H-A, Q or A. I hear an N or an H. 9, J. I heard a 60, not a lot of certainty. This is TTA. It was from a USPS data set. TTA from Marietta. Okay. A. N from New Smyrna Beach. That was a G. Okay. Now, when we saw this and we looked at it, we, at least many of us, made a guess, but we also perhaps felt some uncertainty. I'm not sure. I think this is what it is. Some of us are better at admitting that we don't quite know, right? But I'll tell you, the computer is terrible at that. We would give it these images and it will give an answer and think it's correct 100% of the time, right? And so we talk a lot about ChatGPT and hallucinations, or giving false responses. And this is one of the challenges, is when us as people look at something we're not certain about, we're able to give an answer, but we're also able to say, I'm not sure. I have some uncertainty. Our AI systems are quite bad at that right now. I asked ChatGPT what these letters are, and it said they appear to be symbols representing chemical elements. And it proceeded to make up some chemical elements that did not exist. Okay. And I think it said that because of how I laid it out, right? They're sort of spaced. Okay. It did know to say, probably because it's been primed, given the handwriting, some interpretations may vary. So that's actually a very good outcome, but I was able to give a little, caveat at the end. I gave it another example. I said I worked a lot in agriculture and plant science. So I gave it a drone image of some corn plants. And I said, what's in this image? And it was amazing. I mean, it is pretty phenomenal. I gave it an image and it was, they'd say, rows of crops planted in the field. I asked what type, what kind of plants are these? And got it right amazingly. Young maize. Okay, now I will say probably 99% of the images of fields on the internet are of maize, so I could have given it a harder problem, but it did it well. And then I asked it, how many plants are in the image? And it guessed approximately 7,111, is way off by an order of magnitude. And this time it didn't give a caveat, but I'm unsure. So it's just an example that it's not so great at knowing when it doesn't know. I have a question.
Does the AI, when it's presenting these answers, indicate a degree of confidence or how probable their answer is?
No, most of these systems right now do not. It is active research for it to be able to do that. And I'm going to talk a little bit about my research to try and come up with confidences for answers, but generally they don't. So if you go online and use ChatGPT, it just gives you an answer. It can give you a very wrong answer. And unless you check, you might not know that it's incorrect. Okay. This is an old example from several years ago, but I just really like it because it was a clever name. It was the authors called it The Elephant in the Room. It was a photograph of someone watching television, and they just cut and pasted an elephant into the image. And then they said, please identify the objects in the image. And it identified a person, a laptop, and various things. But as they moved the elephant around the image, it changed the answers it gave. Sometimes the cup would go away. Sometimes a handbag would turn into something else. And so it shows that it's doing amazing things, but they're not as reliable and trustworthy as we'd hoped they would be. Oops. So I'm going to talk a little bit about just very basic of how these systems work, and then come into some of the things that my group is working on to solve some of these challenges. This is an example of just a general, more traditional AI workflow, and I'll talk about how some of the changes are of what people are doing today. But let's say we wanted to develop an AI system that could tell these two types of parrots apart. And so what we would do, I said data is the fuel that runs this whole show. We'll start by collecting a lot of examples of images of the two types of parrots, and we'll label them on which one they are. So this is our training set. And so when we collect a training set, then we start to, well, before I go here, I'll ask you. If I gave you these examples, how would you tell these two types of parrots apart? What types of clues might you? Colors, size, shape of the beak. The macaw has these striped patterns that the Connor doesn't, right? And so we identify features that we can tell them apart. And this is exactly what an AI system would do. A more traditional system is we would pick out those features and we'd say, okay, perhaps we care about the amount of blue in the feathers and the number of stripes detected. We measure those on each image, and then hopefully it clusters those two types of parrots. And then what our AI system does is it first makes a guess. Oh, perhaps I draw this line in this feature space. Can I tell those classes apart? Of course, with this, where it's going right now, it does a poor job telling them apart. But through iterative learning, it says, aha, I can place a decision boundary here. And I can say, okay, anytime I measure number of stripes and amount of blue feathers, I just see where it falls relative to this line, and I can make a classification determination, right? And so this is the general workflow, is we'll start in a training phase where we collect a large amount of labeled data. We extract features that are important to that problem that we care about. And then we train a model, or we learn that decision boundary in that feature space. And then when we get test data, now this is unlabeled, this is ones that we actually want to classify, we pull out those same features and we just see where it falls. And then we can say which class it's in. So this is a simplified example, but it's essentially how these systems work. Now the change to what folks are doing now is that they automatically learn those features as well. And I'll talk a little bit about that. But one thing in this workflow, we often spend a lot of time and all the attention, sort of the glory goes to this part of the learning the features and the models. We hear about ChatGPT 5 or Sora or all these amazing models, but the workhorse is the data. Okay, and so the real bottleneck of making these systems work, it consists of data collection, labeling, and when you spend time here, you get a huge impact right? And so that's why a lot of these ChatGPT models they're trained on all our data, right? So they have using everything that they can capture from the internet or any system where they can get access. And that's been one of the major changes that make these systems function. So I said this underlying technology is the same as it's been since, the 80s and earlier. The big change, the mathematics are the same, but the big change is our computing capabilities. We have a lot more powerful computers and we have a lot more data. Okay. Okay. And the models we use today, I had a very simple example where I was drawing a line. The models we use today are extremely complex. And essentially each one of they often draw them like this because this is like a graphical description, visualization of these artificial neural networks. But every one of these nodes draws one line. And so you get millions of lines and you see where do I fall relative to all of them to get an output. Okay. And by being able to learn all this together, it not only learns the classification or the output we're interested in, but it learns what features we should pay attention to as well. Okay. Right. So we learn them to train those features. And to do that, we need a lot of data. And so this was a quote from one of the, I believe, a co-founder of OpenAI. So this is the makers of ChatGPT. At a conference last year, he said, data is the fossil fuel of AI. And he also said, at the time, we've achieved peak data and there will be no more. Okay, so this was an alert to the AI community saying we're going to have to be more creative. We can't just keep on throwing more data at it. We have to figure out how to make better use of what we do have. Oops. Okay. And so there are these challenges. The AI methods we have are really best suited for enormous amounts of data, which we've talked about. They're best suited where we have training data that covers the cases that we expect to see, right? And so when it has lots of examples to learn from, we can trust its outputs more. But when it has to try and extrapolate beyond examples we have, this is when it hallucinates and gives us answers we can't trust as well. Another question.
Data has different degrees of quality, of reliability. And so one of the issues would seem to be how reliable is the data? How verifiable is the data? To what extent is that being addressed?
Yeah, that's an excellent question. And it really depends a bit on the use case. I'll say for a lot of when we're developing AI methods for scientific purposes, we'll often take great care to clean the data and make it as reliable as we can before we develop a method. But for these really widely used systems, the hope there is if we give it enough data, there may be an error one way, but hopefully another data sample will have an error the other way and they'll cancel out in the long run. And so the idea is let's just give it as much as we can to learn the general structure, and hopefully some of these discrepancies will wash out. And I'll say this is also where there's lots of discussion about how trustworthy these systems are, because the data sets they use may be biased. And so then the outputs are then going to reflect whatever it saw, right? So, but if it says everyone that grew up in Florida went to the University of Florida, my sister would be really upset because she went to Florida State. But if there's more examples of that, it's more likely to say that, right? There's another question.
I don't understand the comment that we've run out of data or we're not going to ever have any more data. Could you go back to some basics and explain what you mean by data?
Yes, so the question was, I don't understand the comment that was made about that we're going to run out of data. I think that was a bit, so this was a comment made by the co-founder of OpenAI. I think it was a bit of an exaggeration, sort of trying to make an alarm. But what I mean by data is really just any image, any digitized text, any information that these systems can capture. And we are making more data, but the speed at which these current AI systems like ChatGPT are making use of them, going through them, far outpaces the speed at which we're generating data. So you can imagine these have been trained on, our decades and decades of information we've put out on the internet. And we've trained it all. We're not adding to the internet at the same speed as they're consuming it. And that's really sort of the comment they were trying to get at. And so he was saying we either need to find alternative sources of data or we need to be more creative with how we're using it. Instead of just saying, let's throw it at the system and hopefully the errors wash out, perhaps we should be a bit more intelligent in how we use it. I hope that answered your question. Yeah. Okay. And so, it's making amazing outcomes, but there's many challenges. And so how do we begin to address these? I mentioned this data limitation, particularly in scientific applications, is a common bottleneck. Okay, and so I'll give some examples. I said I used a lot of work in plant roots and soil. Here's one type of experiment we often do is we'll collect data in what we call mini rhizotrons. So we'll go out into the field and insert clear plastic tubes, and then we send a camera down the tube and collect images like this of the roots and the soil that happen to be growing around the tube. And we'll go back to the tube over time and see how the roots are changing and how the soil characteristics are changing. Now, one of the things my plant scientists are really interested, the ones I work with, in saying, can we breed crops that, for example, sequester more carbon in the soil? Or can we breed crops that are more drought resilient? Or make better use of the resources they have access to. And to do that, they really want to know what root characteristics they should breed for. And so they care about things like root length and diameter, color, volume. And so we need to capture all of that from each of these images over time. And it's extremely tedious. So essentially what we did was hire teams of undergraduate students to take these images and trace out each individual root. And some of these roots you can see. I'll tell you, there are many teeny tiny roots that are very, very difficult to see. And it's incredibly tedious and time consuming to label these, to train the system. It would take hours for one image, and we were collecting thousands of images at a time. Yes.
Perhaps I misunderstood, but I thought you said your research does not touch the object. And why don't you put this clear tube when you plant the plants and see how it develops?
Yeah, so the question is, I thought our research, we didn't touch the object. So this is, maybe it's a little bit of a cheat. The roots are touching the plastic sleeve, but it's not touching the camera. And it was really one of the only ways to look at field root dynamics. How do we look underground? We've tried to develop X-ray systems and look at things like ground penetrating radar, but they have limitations. Of course, this also has limitations. We do generally insert these tubes right when we plant. So at the same time we plant, we insert the tubes and then the plants grow around it and we look over time. So that's one of the advantages of this system is it's not destructive. It doesn't hurt the plant. More traditional ways of looking at plant roots were actually what they called shovelomics, which is you take a shovel and you plow the plant and look at it, and that is certainly destructive. So, you know, perhaps the remote sensing aspect of this is questionable, but certainly it's incredibly tedious to label these roots and use it to train systems that can pull out the root characteristics. And also it's very error prone to try and get all that information. This is a destructive option that we're doing, but we also have been doing X-ray CT scans of soil cores. So we go out to the field and we drill out a core of roots in soil and we take it, actually we image these at the vet's office, the CT system they have for cows. We laid out these soil cores and we got these X-ray CT scans of field collected soil cores, and then we're able to run our AI algorithms and separate the roots from the soil and get 3D information about the roots. Now, to verify how good this is and to train that system, the 2D slice was incredibly tedious to label. This is orders of magnitude more challenging for our team to try and get a handle on where all those roots are. Okay. So, you know, data limitation, this is something that was brought up in the AI community in general. We see it quite a bit in scientific applications like the ones I talked about. And so we need to come up with better ways. Instead of just throwing examples, which is what we do now, can we do something a little bit more, I guess, knowledge guided? So one of the approaches are what we call knowledge guided methods. And so this is work being done by my Ph.D. student, Krishna. And essentially, you know, there was an era of AI early on where we didn't really rely on data, but we were going to use sort of computer programs where we, you know, we wrote out all the possible rules. Someone was going to code up all the possible rules. And anytime you see a piece of data, you would see which rules does it match, and that's how we're going to understand what we're looking at. So for example, if you wanted to make a system that identified a chair, it would say there has to be a seating surface, there, you know. And what we realized very quickly is nothing follows the rules. It's impossible to write that all out. Okay, and so these old systems had assumed they could have perfect knowledge, but didn't rely on data. That doesn't work. Okay, now we've swung all the way over to the other side, where we don't give our systems any knowledge. We just give it tons and tons of data and say, figure out what you can, right? And so we've gotten tons of progress here, but we know more than just data. And so a current trend in the field is to do something in the middle. We have some data, and we have some knowledge that we can feed these systems. Okay. And so this knowledge-guided neural networks is this work in the middle, and essentially the research is how do we do that? We know how to train these systems by giving it tons of data and moving those lines to get out an answer we care about. But how do we come up with a system that does that, but also makes use of information we know about the world already? And generally, there's a whole bunch of approaches that are being studied to figure that out. Some of it is generating fake data that follows the rules that we know and saying, okay, we'll just insert a lot of fake data that's high quality because we generate it according to our models. And that may skew it the way we care about. Sometimes we constrain how the model learns or how it's structured to match what we know about the world. But this is still very much an open research question of how to do that best. And then, of course, what Krishna is looking at is how do I put all these different approaches together? Okay. And so how do we do this? It's really something that requires pretty close collaboration across disciplines. And I think this is part of what makes it so exciting. So my background is computer science, but we really have to work very closely in these examples, for example, with plant scientists, and say what models about how plant roots grow do we know and we trust? And then we iterate back and forth on how we can embed that into our computer science models. And I think this is also another way to sort of get over that data limitation, in that by embedding our knowledge into the system, we don't rely so much on just having vast quantities of data. Okay. I also talked about, so there's just quantity of data, there's also data labeling is a challenge. We talked about how tedious that is. This is a data set I collected over the over the campus of the Southern Mississippi Gulfport campus. Oh. And this was a few years after Katrina. They had quite a bit of damage. And so it was a survey to see if we can find objects of interest and damage in the field. And we went out and we placed objects throughout. And that's me with a GPS unit. And that GPS unit, so I was just starting out, and we got it on loan, and it was not so great. It had a 5-meter accuracy. So when we got those pins, we were like, okay, it's somewhere in this 5 meters is the thing we care about, which translated to 5 by 5 pixel grid. And these were brown and green cloth panels on grass and under these beautiful live oaks. So we would look at these and say, I have no idea where the object is. I just know it's somewhere in here. That's the best we could do. And a lot of times, actually, this is the best sort of labeling we can do. We talked about the challenges with the roots. We get a lot of uncertainty. And so when we're looking at the roots of different plant species, should I annotate an area if it's covered by soil? We have all sorts of questions that come up.
What about the field of archaeology where they do this LiDAR scanning of these hidden villages or ancient cities, and they do this LiDAR scanning and detect these ancient cities and stuff like you were doing? Is that not an area for this AI?
Yeah, absolutely. That's the next. Actually, it is an area for AI using LiDAR. Actually, the color information came from a color camera, but the height information came from a LiDAR system. And the reason we were putting these panels out there and collecting this ground truth through these GPS coordinates is to help train our AI system to learn from the LiDAR, to be able to detect these things and understand the information. So just like when we were talking about the parrots, we got to start with some examples where we know what they are and where they are. We train the system, and then we can start using them. So that was an excellent question. But when we're trying to get these labels to learn from, we have a lot of questions that come up. There may be some soil over the root. Should I label this or not? Or all sorts of uncertainty. And so another area of research is how can we overcome this data label uncertainty? And the easiest and by far the most common approach is just ignore it and hope it's not a big deal, right? And this is what we're doing now with ChatGPT. Because we don't label, we try and use as much data as we can. And often that works, but sometimes it doesn't. Okay, and so there's a whole field, many different strategies to try to overcome this. The one my group is working on is active or interactive learning. And the idea, I don't know if we can start the video. the idea is when we get an object, we label it. And as we label, the system will show what it's learning. So we said, okay, I want to tell the broccoli floret from the stalk from the background, and it'll give us an answer. And then we can examine the output and iteratively refine our labels until we get the output we like, right? And so here, instead of just labeling and hoping we did good enough job and that works out, we have some feedback, right? And how to do this well, and the strategies for that is a big area of work. And so there's many strategies of how to do this, but one thing none of those do is they don't incorporate human factors into that. So we have a ton of computer science research saying, well, we can do this interactive learning, and we just need to get 10,000 samples of someone doing this. And so wait a minute, I try and collect that data and my students get tired, or their hand starts hurting, or and they don't want to mark it as precisely because they're just getting bored with the whole thing. And so this is their next area of work, is that we're trying to say, okay, we do this process, but we also want to take into account what is the trade-off in human factors. So perhaps someone's annotating it on an iPad versus a desktop computer. And we can see overall our user trials, which one is giving us more accurate labels that the system can learn from, which one do folks, are enjoying the process more for longer, these sorts of things. And so we're doing studies of when we compare different annotation methods, bringing in human factors, how quickly do we get to a good answer faster? Okay, so this is our next step of incorporating human factors. And we've done some things of looking at different plant types and comparing different annotation methods and seeing what our end result is when we account for, folks take more breaks when they use the desktop instead of the iPad and these sorts of things. Okay. So I talked about data limitations and how we're trying to embed knowledge into the systems. I talked about data labeling limitations. The last challenge that I'm going to talk about that we're working on in my group is going back to my first example of having these AI systems say, I don't know, or having some measure of their certainty or uncertainty. So here's another example of work we've done where this is in forest ecology. We have a project called ID Trees. So you can see these at visualizeidtrees.org. And there's sites all over the US where they've flown aerial systems, and we have detected each tree crown. And we're working on identifying the species of each tree crown so people can do large-scale forest ecology. And we've detected over 100 million trees. And it's, my understanding, I'm not a forest ecologist, but my understanding is traditional methods is walking through a forest and taking notes. And now we've gone through, getting tens or hundreds of observations to hundreds of millions over large swaths. Okay, so it's really revolutionizing that field. But when we look at, and I'm sure if you go to the website and look around a little bit, when I show that slide in one of my classes, a student will look it up and say, I found something you got wrong, okay? And so there's certainly errors. So in this case, there's a river, and it marked some of the river as a tree, okay? And here's looking at the roots. Sometimes there's bubbles on the tubes, and it says, some of the bubbles are roots and things like this. And once we know this is an error, we can change the label and the system can learn from it. But the problem is we don't know that's an error until we run it, right? And the AI system didn't say, I put this as a tree crown, but I'm not sure. And so how do we get our systems to say, I don't know, right? And we generally call this systems with competency awareness. Okay. And there's a lot of approaches in the literature to do this. We sort of classify them into two groups. One is supervised learning, where we give them examples of things that are what we call out of distribution. So weird examples that it wouldn't expect to see. And it gives an output, and then we say that was the wrong output. This is what you should learn. And then unsupervised approaches, where it tries to understand the training data and says if anything's different from it, we would call it an outlier. I am philosophically opposed to that first method, because if you knew what it should call out of distribution already, then you don't need to find them. You would just enfold that into your training data. I like this approach where we characterize what we have and then we find stuff that's different from it. Okay. And so, the way we have been looking at this is I talked about these artificial neural networks and how every one of those nodes is drawing a line. Okay. And what we do is when we go from one layer in our network to the other, we can do, we look at how we fall within all the lines in that area. And, in this example, the number of nodes is staying the same. So we're keeping all the information, we're just transforming it. But often in our network, we go from a bigger layer to a smaller layer, because we're often going from a ton of information to one output, like, is this a cat or a dog, yes or no? And whenever we go from a larger layer to a smaller layer, we're ignoring stuff, we're throwing stuff away, okay? And we call that space of things we ignore the null space. And so the idea that we have, and this is my, actually Matt just graduated, so he's Dr. Cook now. This was his dissertation topic, was let's look at what we throw away. And if what's being thrown away on the test sample looks nothing like what we've ever thrown away on training samples, then we can call it an outlier, an out of distribution sample. And it's really interesting. He has a picture of his dog, and he trained a network to detect the dog. And then he added some noise from the null space, from the information that's being ignored. And he added that to the image. Now, when you pass what's being ignored to the network, it says there's nothing there, right? It gives no output. And if you combine the two, it thinks this image is a dog, because all that noise we added is just being ignored. And so the idea is we can look at what's being ignored. If that's strange, we can say this is an outlier. This is something we don't know. And so, for example, this is a visualization of a large common AI data set. And I'm going to sort of flip back and forth. This is the space of things we have seen in our training data. And when we give it outliers or things it was not trained on, they'll often fall in these gaps, right? These other spaces. And so we're able to say, if you fall in these gaps in the spaces where our training data isn't, we should say, here's my output, but I'm not sure. It's different from what we saw in training. And we can get really good performance when we compare to our competitors in this space. So that's, I guess, what I had to show. I wanted to share a few of the things that we're working on. And also, I hope I gave some overview of how these AI systems work. Everything we're doing is really driven by my amazing lab group. And I'm happy to take more questions. Thank you.
Hi, thank you for that. That was wonderful, informative, and slides were great. My question is about the data curation when AI scans the internet. How does it do that, and at what level? So, for example, does it consider the meaning of every word on a web page, or on a publication that is linked to whatever the topic is? Does it look at every word? Does it look at sentences, phrases? How does it make AI sense out of what we would visually see?
Yeah, so there's a little bit, so thank you, that's a great question. And I'll tell you, it's hard to answer, partially because we don't entirely know. Okay, and so I'll tell you, I showed these really big models with all the neurons being connected, and a huge area of research is what they call explainability. Can we understand how they're working and why they're working? So what we do understand is what we feed it and our training mechanism, and we understand like sort of low-level operations. And we understand the output and how we drive it to learn, but the internal mechanism is still an open question of, can we explain what it learned, why, and how? So part of it is, unlike these systems, I can say I don't know, and I'm not 100% sure. But the other part is we do feed it all the words, all the information we get. And our most current approaches is we'll pass in, for example, a large group of text, and it learns the relationships between the words. And essentially it just sees many, many examples of that. And it uses that context to try and understand the meaning. So I guess what I'm trying to say is we absolutely use every piece of data or information from the internet we can get. We keep it in context. We give it the full view, and it learns those relationships to get the output we're interested in. Yeah.
I have a question. If I ask ChatGPT a question in English, will it search Russian for answers? And how well are the translations? And do they correlate with what I'm asking about?
That's a good question. I think the translation systems are getting better, that they are using, there are a lot of devices and things out there that will translate on the fly as it's hearing things. My assumption with not working for OpenAI and not knowing exactly how they work is that they would use all the information that they have available. So if they have a Russian website, it's going into the same model, but I'm not 100% sure on that. But if I was developing it, I would have one model for all of it. Yeah, that's a good question. Thank you.
In upstate New York, there's a fossil fuel generation plant being built onto one of the Finger Lakes for cooling, water cooled. And when asked what it's for, it's to create the power for the AI. So AI uses a lot of electricity. What is your view on the infrastructure to support this rapidly growing and, of course, taking away from other uses?
Yeah, I think this is a very important question, that one we need to spend quite a bit of time, I guess, as a society thinking about how we want to allocate our resources. I'll say they're just like, as someone that develops AI systems, I think we often develop systems to eventually be more efficient in our usage. So when we're training these large systems, I'll give an example. So for our plant root work, we'll often develop large systems with the express purpose of trying to find out what information is essential for this. So then we can scale it down to very simple systems that don't use as much energy. But that first stage is important to try and understand what we're doing. So I think like a lot of nearly all technology, we're learning as we go. We do get more and more efficient. If you think about sort of our Chinese DeepSeek folks, that DeepSeek model is very effective, uses a lot less resources, right? And so we're getting better as a whole. And I expect that trend to continue.
I have a question somewhat related to that, and it's in data management. You have these gigantic data sets, and once you've curated them and have these hundreds of hours invested, where do they reside? Do you have to reserve system on the time on a supercomputer to get them into existence in the first place? How do you share them? What happens next?
Yeah, so for our work in our lab, we do purchase and reserve time on the UF supercomputer, the Hypergator. So our funded research, a portion of those funds goes towards that for the express purpose of storing and analyzing the data. Most funding agencies require what they call a 5-year data availability. So after your project ends, you have to make your data available to the research community for at least 5 years after that. And so in the research world, this is very common. We do all that work and we make it available to others. And it's a requirement of the work we do. Commercially, it's more of a consuming data where it resides and then putting it back, right? So they'll ingest it, make use of it, and not store it, right? And so that's most of the commercial operations, just because the volumes of data they're dealing with is enormous. So they'll ingest large amounts of data, do partial training, and then move to the next data set and maybe return to it, but they're not storing it for long, indefinitely. So it sort of depends a bit on the purpose. Scientific community, we have a lot of sort of expectations and requirements in making sure it's available.
As a former gardener and a non-scientist, I kind of know the questions to ask if someone is getting a much greater yield than I am of a particular crop, the soil, the climate, and so forth. And it would seem to me it would be a lot quicker to start from that bigger place because you know the questions to ask. Why is this individual, let's say a Japanese gardener, why is he having a much greater success rate than I am, given that let's say we're even using the same seeds? So thanks.
Yeah, thank you. And I think that's a lot of the motivation for the knowledge-guided machine learning work, saying we do know something about the world. Why are we ignoring that and just collecting vast amounts of data to relearn what we already know? But the research question there is, how do we take that knowledge and embed it in the system in a way that's used properly alongside the data that we do have? And that hybrid is important because earlier AI systems where we just relied on our knowledge had big gaps, right? Because there are things about the world that we don't know. And so this sort of hybrid between relying on observations and empirical data plus embedding knowledge, I think this is the future of where AI models are going. And so I completely agree with you. We should start there. I think when it comes to work with plant scientists, I think a lot of their questions that I'm hearing is, there's a lot of things we know, but then there's a lot of things we don't. And for example, when we're looking at plant roots, it's just hard to observe it. So there's lots of theory, but how do we collect data to really understand how water moves through the soil into the roots, right? We have a lot of understandings, but it's very difficult to measure. Now, they've got lots of contraptions to measure things in the lab and observe it, but they also know how it works in the lab is not the same as how it works in the field. And once we try and observe it in the field, we're going back to the question earlier, we're changing something. We're putting a tube in or we're ripping a plant out. And so there is a little bit of, we know a lot, we should make use of it, but we also don't know some things. We got to figure out how to observe those things and how to use data to try to fill that gap in. Thank you.
Yes, I'm concerned about data security with multiple AI systems coming online, and people are accessing it from their home in research labs. It's relying heavily on the internet. What thoughts being given to try to protect the data that's being inputted and kept on these systems?
Yeah. So this is also a great question, because these systems are sort of parroting back data that we know. And there's been examples of folks, for example, there's a lawsuit that was recently went through the courts of folks saying my books were used without my permission. And they know it because they asked some questions and got answers back that were almost identical to the text they put in their books. And so this is a big concern. I'll say that a lot of this is policy and regulation, saying what guardrails do we want to put around these AI systems and their companies. A lot of it is, sort of as an individual thinking about when you sign up for another website or another service, what are you actually giving up here? A phrase I've heard a lot, if it's free, you're not the customer, you're the product, right? And so this is true of a lot of, for example, systems where you're saying, yeah, I'd like to get this 15% off, but what they're doing is capturing all your shopping information to use to feed back ads to you and these sorts of things. So there's some, I guess, probably work we need to do in awareness of how our data is being accessed and used. And then there's also quite a bit of work being done in cybersecurity and privacy. I'll say at the University of Florida, we have this group called FIX, the Florida Institute for Cybersecurity. They are truly world-class, worldwide, really a standout group, very well known for cybersecurity at UF. And they're trying to come up with things to do privacy preservation in these systems. I have a colleague, Sanjeev Kopal, who just has worked on, for example, privacy preserving cameras for hospital settings. Hospitals will often use cameras to monitor patients. And can we do that where it inherently doesn't collect personal details like from your face and stuff like this? So that's an active area of work as well. Probably the biggest impact we'll get in the short term is going to be policy and regulation. And then in the long term, it's people being more aware and making the conscious decision if I want to provide this data or not. And then research and security and privacy improving and embedding it throughout these systems.
Something else, follow up on the question that Walter asked about the language translation.
Mm-hmm.
Depending upon I can imagine that depending upon how the sophisticated the decision tree has been built in by the human, because some words in some languages simply don't have a direct translation.
Mm-hmm.
So the decision tree has to determine the context with which the original statement was made to pick a word that might reflect what the author really meant.
Mm-hmm.
And the sophisticated, how sophisticated the decision tree is put together by the human being makes the big difference, does it not?
Yeah, so I think my understanding of the way the systems work now is, yes, context makes a lot of difference. And so this is going back to the question of what data is ingesting. It's usually ingesting, it's not trying to make a translation on a word by word case. It's taking a whole block of text and saying, I'm going to try and translate this all jointly using that context. But also, rather than using decision trees, what they tend to do more commonly now is train these systems to learn from these blocks of text. And then the way the human provides guidance is when it gets it wrong, it says, you got it wrong, go back and fix it, as opposed to trying to fix how it generates the output. It gives it the feedback it needs to adjust those lines, and it provides that error for adjustment. My understanding is these large language models employ a lot of people to just run them, find errors, and give that feedback.
I have a question and a comment. So how unreliable information on the internet is, how much fake information, hoaxes, and so forth. And that is being used to generate our AI systems. If we could have data sets that are reliable, wouldn't we have much better AI systems? And I'm going to refer to government databases. If I, as an AI company, had access to our Social Security system, for example, I probably would have a very successful AI company. So I'd like to hear your comment there. And then I'm going to ask another question. I have been using and playing with medical AI data, and I found that when I tell it use only information from the journals, I get much better information back than if I just ask a general question. So I think there's a lesson there.
Yeah, no, I completely agree. I think there's the trade-off here is that, maybe 10 years ago when we were making AI systems, we spend a lot of time focusing much more on data quality, annotation quality. And we got intelligent systems that were reliable and we could test them for particular use cases. But what they were not great at is generating conversational text and generating it quickly. And so the internet and the large volume of not perfect data is what's given us enough to learn how people talk to each other. So the quality of the outcome is not as reliable when you use the general internet. But the general internet is what gave us the ability to have a conversation with ChatGPT. And so I think what the work is doing now is exactly what you're talking about. We're now coming out with tools that say, limit the answer to coming only from journals or limited to only coming from scientific data from universities. But the only reason we're able to do that is because we had this era of using just all the internet data. I'll also say I talked a little bit about our scientific data being limited. That's because we don't have the entire population of the world, writing notes on the internet to generating it, right? You only have so many scientists in each field collecting this sort of information. And so that goes back to the question of we're running out of data, or we're just not producing it as quickly as we're consuming it. And so to me, of course, I work at a university, but I think this emphasizes the importance of university research in this time, is that we need to collect high quality scientific level data that we can leverage and use both in these systems and for understanding the world around us. And so.
There is a question online here. It says, I get several communications offering 28-day programs, 15 minutes a day to change my life. by learning all of the AI applications? Are they worthwhile, in your opinion?
I don't know if I don't know these particular programs or whether they'll change your life. I certainly think that understanding the AI systems more, especially as we're interacting with them more and more, is valuable. If we're talking about changing our lives and that we want to focus on AI, I say come on down to Malachowski Hall and take a class there. Yeah, okay.
Thank you. I think if you have more questions, maybe they'll be answered in the next few talks that we have.